Hello, hello, everyone. Welcome back. Today, we are going to be working more on the new file system stuff and TTYs as well. The sort of two most common appearances on this stream. But I've hit a point where I think I have a clear path on what I want to do as far as abstracting the new file system and abstracting the TTYs to work with that. So I think that's what we're going to work on today. So do not disturb so I don't get bothered. So where are we at? I did a stream some time ago, probably like a month ago, where I started trying to run some ideas about replacing the file system in the Nightingale kernel. I thought it was a real mess at the time, and I think that even more so now. At the time, I decided that it was really bad viewing because I had no idea what I was doing. I was doing a lot of reading. So in the intervening time, I've done a bunch of design work and a bunch of implementation for, you can see I'm on this branch here called FS2. And I have something that does a bunch of file system-like things. I've got this test program. It creates a hierarchy of files and directories. It has symlinks, it has hard links, it reads files, it writes files, it checks permissions, it's running stat, right? It's verifying various different error conditions. And I have pipes implemented. And I'm almost at the point where I want to flip over and start using this for the real file system. Right now, this is still a different set of syscalls. It's not the same, or if I run ls, this is not the same files you can see. So I'm ready to start actually using this. So the last couple of things I have to do are hook it up so that things like, well, the shell has to work. That's kind of important. So I want to hook it in with TTYs, and I know that I don't want to do what I'm doing right here. Something that I'm really trying to go with in the new system is there's none of this just like create a file at global scope and use it. I'm really trying not to do that. So far, everything I've been able to avoid it. Everything is actually allocated on the malloc heap. There's no like worrying that, well, when some files get deleted, they don't get freed, but other ones, when they get deleted, they do get freed. I'm not dealing with anything along those lines anymore. So I need to change this approach, which I think is going to be the most invasive change that I have to deal with. As well as having to decide, like at the moment, I've got this idea of serial 1A and 1B. I don't think we're going to preserve that for now. I've got some ideas on how we could get that sort of thing back, but TTY is probably going to be the thing that has to change the most. And I know a lot of this will need to change anyway, just because I do want to be able to support a bunch of more advanced TTY features. So things like having this switch statement with hard-coded control statements is not really where we want to be long term. But the first thing that I think we're going to do here is do a little bit of abstracting in the serial file, because I think the first problem that we're going to hit is that these serial, they're not even instances, right? They're not objects. I just have these sort of bare functions to write and read serial 1 and serial 2 defined as com1 and com2 on x86. And so the first thing that I want to do is dynamically allocate these, and dynamically is going to mean sort of machine independently. I am going to hard code dynamic allocation of the first two. But I want this to look more like maybe a serial device that has some internal state. Maybe on x86, this is probably going to be the COM number, but it's got some internal state. I don't know what we'll call that yet. It's going to have a read a single byte function and a write a single byte function, right? And that's it, right? That's going to be the whole serial interface. And then things like the TTY, when they want to interact with that, will just have a pointer to this, so that I'm not going through and like flipping these function pointers around. I've just got like an object for serial 1 that you can pull out of a registry or a table or something. So what is that? What is that signature? Well, why does read take a byte? I don't think that's accurate. I think we're not gonna preserve that. I really think it's that. I don't know why I'm doing all this nonsense. And I think for now we'll probably just say like port number here with a to-do that this should be machine independence. And this will end up being in the header because we're not going to want this here, but I need to at least be able to, you know, read it for now. So write stir becomes a little bit more interesting because we actually have I need to be able to write to a serial device. So this is now a helper function. Comma void. So then that becomes write byte. This is maybe not actually the right place to put this, just on the grounds that unless this can optimize, which is now we're talking about eating a virtual function call on every byte. I don't think serial output is enough of a bottleneck that I'm gonna worry about it right this instant, but definitely a possible avenue for improvement is whether we want to actually just do the write a whole string inside maybe the drivers. So then the other question is, where are we going to initialize these things? Right now there exist no serial devices. So I guess a couple of questions. A, where do we write these functions? Do we write these here? Do we write these in the machine independent or the machine dependent section? And I think that's probably true, is that we probably do this in Arch x86 uart. And it just ends up replacing x86 uart, right? Yeah, or ends up being used as x86 uart, right? So let's just paste this in. Well, no, let's use a second pane. So we're going to want to put serial device in the header. Goodbye, old. No, no. And actually, we will still want, we shouldn't get rid of the we should not get rid of serial write and serial read because we will likely want those to be the same as this, right? They'll just concretize the virtual function calls the same as this, right? It'll just call, you'll pass in the dev and it'll call through. So we won't get rid of those just yet. We may decide to get rid of them later, but for now, we didn't even have a write function for serial 1. Lots of very creative decision making happening in this file. Okay, and then now that we have that, we can open it over here so I can actually read it. Set colors in the terminal. And you guys can see that, yeah, there's no issues with the webcam. Cool. So we're going to make a couple of changes here. Write byte is not going to take a port adder T anymore. It's going to take a port number. And I think we'll end up with a lot of yeah, see, we already actually had that same write string function, so I think we're actually just going to go for it now. Because there's no changes needed to this file. Okay. That's our read and write functions. The rest of this is not. That's an interesting point. We do have to deal with the IRQ handlers. So we haven't fully figured out what we're going to do there. Actually, instead of doing this as individual function pointers, we should probably do this as a like serial ops so that we can, because you're not going to have different serial devices in the same driver that have different behaviors. So this way we can just have a like ops so this way, well, it would help if I wrote that. It's basically object orientation, right? I'm making a virtual function table, a method table, if you will. And then just when we create these things, we'll set it up and it'll be fine. It's fine. Should have the same signature now. Yep, as x86 UR read byte. write byte is x86 uart write byte. And right. Okay. So if we make a new one, it'll look a little bit like allocate it. Initialize with what is it called? The port number equals address. Ops equals x86 uart serial ops. And this also lets us make all of this. These we can now make internal, right? These are no longer, they no longer need to be global. They don't pollute the namespace anymore. And in fact, honestly, everything in this whole file should be static. Most of these are. Enable interrupt, disable interrupt, IRQ handler. Okay, so that's, we're definitely not, well, we kind of have to deal with that. So yeah, so the next question is, what do we do about TTYs? And I think the answer is probably that we want to just have a pointer, right? So TTY is like attached to a serial device, but that happens after boot, right? They're not, right now they're sort of inherently tied together. And I have this just like hard-coded, hey, if it's com1, write to serial TTY com1. Which is dev serial 1A, but then that can be switched. Yeah, this needs to go away. So the question then becomes, how are we going to design the TTY? So the TTY is probably going to need this write to serial TTY function is essentially going to have to be a virtual function on the TTY. Yeah, so just like we have this print fun, we're going to have another one that's like void star. I don't want to call it write to. That's always been confusing to me because it sort of feels like you write in and then you write out or something like that. So I want to call this, for putting data in, I don't know, my intuition is like push byte. I don't know. We'll see how we feel about that. I do think all of this buffering is a little ridiculous. A ring buff for a TTY is a little ridiculous. 1024 bytes of, well, okay, no, the 1024 bytes is for line buffering, so that might be reasonable. The ring buff I think is a little ridiculous, but I'm not going to try to change that right now. And if I was going to push a byte, I would probably want to have a byte argument. let's see. And then, so the other side of this is the print function is currently based on the idea that you can communicate information about where to print with the function, like the function that goes into this function pointer is different currently for serial 1 and serial 2. So I think we're going to end up with sort of bidirectional pointers, which might be a little bit messy. We'll see if it ends up causing us any problems. The thought being here that we'll tie them together 1-to-1. And so the TTY will have a pointer to the serial device, and the serial device will have a pointer to the TTY, and that lets them each know about the other and talk to each other. This is certainly not scalable in a world where you could have like a virtual ETY, like a virtual TTY, something like if you think about the TTY that's controlling this window, there's no physical serial device for the window on my screen. So there's a virtual terminal going on there. But I think for now, I could introduce some sort of like print abstraction, but I think for now we are just going to give it a pointer. And we'll deal with that later. And we are not going to have that anymore. And we are not going to have that anymore. So write to serial TTY becomes, we do have to figure out we have to be able to turn a port into a TTY, because we need to be able to turn this IRQ handler into what do we do with that. Which there's an interesting point here, which is that x86, there are 2 different interrupt handlers, but there are up to 4 serial ports. And I've just ignored that, right? I've only used the 2 because I attached the serial port number in the interrupt handler, right? So if I was going to keep ignoring this, what I think I would do, if I was going to continue ignoring ports 3 and 4, what I think I would do is I would just change this to be the device, and then I would read it like this, right? I would have my serial device C is dev read byte. If I can type on this keyboard, it's a different keyboard than I'm used to, so sorry if this is painful. Dev read by dev, and then if dev TTY exists, dev TTY push byte dev TTY C. And that's it, which is nice and convenient. The interrupt question is probably valid. Easy enough to deal with. Oh, this is funny. So at some point, obviously the type here was port at some point. And at some point I did a find and replace for port to port adder T. And I didn't look at it very carefully because support adder T. For now, I only support interrupt on data available. Yeah, well, I found and replaced port. So it's good that we're deleting these things. So enable then is going to look a lot like this, except it's going to have a this needs to be struct serial device. Okay. UR enable interrupt. Boilerplate. Com becomes P, and then this is a byte, so the value is if enable, then it's 9, else it's 0, and we'll just write that value instead of having two separate functions, which saves us the trouble of having two separate functions. Okay. So that's good. We are not going to so that's yeah, I think the main remaining open question is, do we initialize the two serial, do we initialize these data structures now? Like by now I mean at init time? And I think the answer is probably yes. We probably do want to just get these created. So we have our new, well, okay, the question that's going to inform how difficult that's going to be is, where do we enable this? And very conveniently, I mean, I already said it. Serial init needs the heap to be initialized first. Thank you, past me. Because now I'm going to be allocating in serial init more. I mean, obviously I was doing it. I was doing it because of the IRQ installs. IRQ install can allocate. But now I'm going to be very directly allocating, because I am going to be allocating the whole TTY. So, which honestly we should probably do like in setup. This can be static too. So what we will, I say allocate. No, so what we can do is we can make a serial devices again with the, this is not, I mean, this is in x86, so it's not actually the end of the world. This definitely needs to include serial, which it didn't before. PRST serial.h. We can make serial devices for I don't know, x86 com1 and 2. So these are just pointers at global scope, and then in init we will do this allocate that we did, new x86 UR dot enable x86 UR enable interrupt. These names can also be made shorter now that I'm not now that I am not exporting them. So that's definitely an option. Just like we have is transmit empty, is data available down here. Which I've moved these things around. This is probably going to break stuff because these are static and not in the header, presumably. Maybe they're in the header. Not interrupt. are not in the header. And in fact, a lot of these things aren't going to exist anymore. Init, yes. These don't exist. These don't matter. And then we said we're going to make again, I don't think I like these just being YOLO global, but I don't really have a good service discovery system for the TTY later to be able to find them. Which maybe we should do this as x86 com. I think we'll do an array of 2 pointers. Because we are going to create these files later with an index. Like the TTY files are going to be made with an index into that array. So this is probably what we're going to do. And then we need to include serial now because we're using it. We're using struct serial device at this point, so we're going to need it. Okay, that's not what I wanted. I think we are pretty close here, actually. So yeah, so the last thing is we're gonna x86 com 0 is gonna be new x86 uart. And then do we take that port address here? We do. This should really be com1 and com2. And then these are where this used to just take the the com number sort of smuggled as a pointer. Now we're actually going to pass the real thing. Okay. That seems very reasonable. Did I delete? I deleted the headers. I keep going there. I don't want to go there. I deleted com1 and com2, but I do not want to delete com1 and com2 permanently because I just used them in this file. So we're going to put them over here. And they're really bad names, right? Com1 and com2. That's fine for a C file, but those are terrible names for a header file. So I'm glad I'm getting rid of those. Okay. We discussed that we needed to declare these. Just because those are not anywhere else, so I need to have them be pre-declared before we use them. Okay, so next, we've made a pretty big change to how TTY works. Specifically, write to serial TTY. Well, right, this is this whole thing. So, So this is an interesting point that we are dumping this. We're dumping this. We're dumping these. Those. So we still have to deal with the files. That's another point too. We're not dealing with that. The file stuff is going to be somewhere else. Specifically, this is going to be kernel fs2. We're going to make a... It's not going to be in care dev. It's going to be in, we'll call it serial.c. So let's see what's in care dev.h. This is going to look a lot like character device.h, which is literally nothing. So we need basically nothing here. It's going to look something like this. We are super not. Okay, so the way this worked before was write was calling TTY file, TTY, like it was reaching into the TTY file and getting the TTY. And read was again reaching through into the ring and reading data out of the ring buff in the serial buffer. So we're super not doing this anymore, right? That's not how this works. So for starters, the new mechanism here, I'm using major and minor numbers. So the first thing that I have to do is be able to actually figure out which, there won't be a pointer to the TTY in the file. I have to be able to get that from the minor number. So we'll have to have like an array of TTYs. Minor device. And we could do some checking, right? Like if file inode minor device is greater than, let's say there can be, I don't know, 64 TTYs or something, return enodev. If there is no TTY, return enodev. With the TTY, we'll probably for now do the same thing. Except that so as discussed, printfn has to change, right? And it is changing because we're using serial device instead. So it'll be serial device write string 4 now. Which, if we wanted to cheat, we can do something like this. We will need to include serial here for now. Because, so, the reason that I keep saying is like this should not, right? Like this isn't even going to be dev serial. This is going to be like a TTY file. So it shouldn't be tied to a serial device at all, but we're cheating for just the hot moment. And we'll write that down in a moment. I don't know that that's, if there's no serial device, I don't know that enodev is the right thing to do about that, but we'll see. DevOps write string dev data. Okay, and then read is gonna do the same. So the question, I guess, is what is the right to? We still need to mess with right to serial TTY because it's now going to be the push byte virtual function, but we need to figure out where it's actually putting the data. It seems to be putting it in the ring, but I'm not sure I understand why there is both a ring and also a buffer. If the buffer mode is 0, thank you, past me, for being so incredibly descriptive about what buffer mode 0 meant. If the buffer mode is 0, write it to both the buffer and the ring, and potentially echo back. Otherwise, if it's a printable character, again with the highly fantastic, that should have been is print. So if buffer mode is 0, we're writing to both the buffer and the ring. Otherwise, we're only writing to the flat buffer. What does the TTY tool do? Set buffer mode equals arc. Thank you again. Also, we write it into the buffer and then we delete the buffer. So I'm guessing buffer mode 0 means send it directly through to the application. Buffer mode non-zero means hold it until Control D or new line. Yeah, that makes sense. That makes sense to me. Okay. So the ring is for passing it through to the final file, to the reader. If you put it in the ring, it goes to the reader. If it's in the buffer, that is an internal storage in the TTY so that you don't have to notify the reader. You don't have to wake the reader up. Seems right. Yeah, and then the notify happens at back R or back N or Control D or in buffer mode 0. Okay, yeah. So that should be definitely a helper function. Let's just like start with that. Let's do a couple of things here. No buffering. 0. Buffer mode 2. Pretty sure you just don't need that at all. Oh no, okay. You do need that because if the mode is no buffering, write the entire buffer into the ring. That's fine. All right. Well, at least that's a good start. So instead of, so every time we use serial TTY print fun, we have to move out to this serial. That we are going to abstract into a helper function just because this is going to change. We know that we're not going to leave it this way. So I am not going to pepper this with, right? I am not going to replace this with serial TTY to serial divide. Like, I'm just not going to do that. So we're going to make a like print to user TTY. And actually this serial TTY is a TTY. So this can even incorporate the if echo behavior. I guess the print function is only ever used for 1, 2, or 3 characters, but it still would be really annoying to and we could size it automatically, but that makes the single character case a little annoying. Okay. And yeah, so this just becomes clen. And then, yeah, so let's just go ahead and kill every instance. Yes, but it's not this anymore. It's TTY serial device ops write string TTY echo and cool. TTY serial device. Cool. Okay, so now we should just replace every instance of this with print to user. Which I think there were a couple. Oh, here's more. Yeah, doesn't. Oh, because this is a string. So you do actually have to do this out of line. Okay. To user backspace. And last but not least, oh, I think every single one of these is wrong. Yeah, I didn't put serial TTY in there. Okay. Print to user of paren quote needs to become print to okay. Next, just a couple more that will help not have to do this much. I just want to deal with the like buffer manipulations somewhere else. So like buffer flush, right, is going to be the ring. The ring right, set the buffer index and WQ notify. WQ notify needs the file, so that's fine. This is going to end up being an FS2 file. And we said we're not going to be able to get the TTY. Well, we need to, okay, we need to solve this problem in, didn't we already solve this problem? What did I do a second ago? No, I didn't write it. Okay. We're going to need to solve this problem later. So we're just going to have file and TTY and figure out how to get them later. So flush the TTY, flush the buffer, set the buffer index to 0, and notify everybody. Okay. I think those things will always happen at the same time, so... and then buffer push of a single character is going to look a lot like that, except that that's C, and these are not called serial TTY. So that just lets me get rid of this in favor of buff push serial TTY. I really need to change that. In fact, I'm just going to do that right now. For this entire function, serial TTY, TTY. Theoretically, it will be fine. Okay, so buffer push, TTY, C. Print to user, and then buffer flush, TTY. That's the idea. Nice and easy. Look at that. If index greater than 0, buffer flush. Else, okay, sure, other stuff. This is going away, at least for now. That we don't need right now. Okay. This is a buffer push, buffer flush. This is exactly the same as this, I think. This is buffer push. That does nothing. if it is backspace, okay, this is backspace. We'll leave that for now. Because now we're down to one screen. This should be a lot easier to deal with. Theoretically. Should we see how far away from compiling we are? I know this is not going to work. It's certainly not going to do what we expect, but we can at least fix some compile errors. That's never fun when you get to the end of a big refactor and you've got to fix every single compile error in the whole world. So I like to keep it going. Right, this is dev now. You are at serial ops. That needs an ampersand. Totally agree. There is no member called dev arrow read byte. It's dev ops read byte. And too few arguments in enable interrupts. I think we're just gonna say we're just going to enable these this way. That's kind of ugly, but we can come back to that later. And yes. Okay, so that should fix most of the problems in this file. Serial.h is not thrilled because serial device needs to be pre-declared. Since it reads top to bottom, this depends on this, but this depends on this, so I have to just tell it this is going to exist. Kernel debug. There definitely is not going to be a serial2 printf, so we're just going to go ahead and get rid of that. Is that used anywhere? Yes. It's used in the perf tracer, so we're just going to get rid of that. Later problems. And is that going to cause more problems? Yes. We didn't finish this because these need to be true. Enable is now a binary instead of two separate functions. Okay. Kernel FS, yes. This is going to be an interesting pickle that we're going to put ourselves in here. Is that this is going to be real hard to test without actually flipping everything over to FS2. And maybe we'll end up doing that, but what wants me to return something? 73? It would help if we returned it. Okay. Yes, because I moved this out. Where did I write that? This is in kernel serial. So the the idea here is we're going to devirtualize with these. So serial write non-stir is going to just take a character and call dev write byte. We fixed this as well. This is now going to be dev write string buffland. Dev C. Okay. That seems totally reasonable to me. TTY is very unhappy with me because it's never heard of fs2 file. Well, let's let it hear of fs2 file. These are all local for now. It's 2/file. What do you mean no member? Sure there is. Okay. Serial has bad declarations for these things. Struct serial device star comma space. Okay. And you can't comma space void. Kernel serial, it's not dev write byte, it's devops write byte. Clerical work. Okay. Printf. I guess. Except that that's not declared either. That's going to be a bit of a pickle. I'm not leaving this here. Evil, evil things. Okay. Oh gosh. Now this has to take us dev and 20 should return that. Very reasonable request. Good guy compiler. Okay, that builds. So last one is TTY. Buffer flush. Right, okay. So buffer flush is indicative of the problem here. Which is that what we need to do is we actually need to change write to serial TTY to be in accordance with this prototype. Push byte And so there is then, people have to be able to wait on this TTY. People have to be able to wait for data to be available on this TTY. The question is, where? Currently, we do that by attaching every TTY to a file on the in the background, and the file has a read queue. Do we want to keep doing that? Or do we want to attach it in some other way? Like I could have another, I could do like fs2 file. We could do that, and if that exists, wake up anybody waiting on it. That's definitely an option. I'm no longer going to be doing any embedding, right? That's definitely not going to happen. Another option is we could have a wait queue, which is probably the most correct thing, but then I wonder how that's going to behave. Yeah. I think this is what we're going to end up doing, is we're going to just give the queue to the TTY, and so the file, when the file wants to read, the file actually waits on the TTY's read queue instead. And I think that'll be fine. We'll find out. So we'll see. How deeply does that disturb my... Okay, here the identifier doesn't exist. Yes, it does not, because this is C. Yes, okay, so there's other things here that need file, like signaling EOF. But that's another thing that we can do here, is we can say like, how would we... So if we're going to pass reads through to the serial device, how do we indicate, like, somebody said Control D, there is no data, like, this is the end of file for one read, but the next read should read real data. And maybe the answer is we just, right, we pass reads through to the serial device, but we have a, like an internal pass-through function that does things like signal EOF. So instead of file signal EOF, we can just say TTY signal EOF. And instead of file read queue, it'll be TTY read queue, because now we have to do that here too. TTU. That is a surprisingly, it's not read queue. Read queue. Print to user. We missed a couple of these. That takes, because I used the wrong find and replace. Cool. Okay. So that actually all compiles. We are going to make a quick change in debug, because the thing that just failed was that, wow, print perf trace doesn't exist. That's very salient. We are not using perf trace right now, so I am just going to make it a function that does nothing. And that actually like built and installed, which is kind of surprising. Obviously this will not work. Obviously it will not work for surprising reasons, but there's no input output. So yeah. It looks like what's happening is it's trying to run the shell. Yeah, it's trying to run the shell. It's in WaitPid. WaitPid is trying to reap the shell because it's doing something weird with these files. So I think probably if we're going to test this, well, okay. So there are no TTYs right now. There exist no TTYs. So we need to make a way to create them and attach them to the COM ports. And set up push byte, because the theory is that this could be TTY push byte. Which honestly doesn't even need to be virtual, at least not right now. Maybe it will be later, but that can be static. These are, or not static, it can be concrete. These can actually be static because they will never be used anywhere else. And then, yeah, we want like a struct TTY, new TTY. And then we want like a TTY what we called it global TTYs. How did that? Oh, because we're not compiling the file yet. Global TTYs, and I think we said it was going to be 32 large. So TTY equals malloc no, we don't even need to do that because I in place the ring already, so I don't need to worry about initializing this at all. I mean, I could. I'm going to. We're not going to do. This is kind of nonsense. This is only there because I create these things at a global scope and need to like track whether they've been touched or not. If I'm going to have a function that initializes it, I should initialize it. So what do we need to talk about? I deleted the code that creates these things. So we're going to just git stash all of that because I want to find these files. I want to know what I had. Okay. We'll just go ahead and copy this, all the TTY so that I know what the arguments were, the parameters. Push threshold was 256. Buffer index, that doesn't matter. Buffer mode, 1. If we don't have... We have basic, so we can do true. And this is in ng, so yeah, this is going to be a Boolean. This is going to be a Boolean. Buffer mode is a mode. Index is a real index, right? That's an integer. Okay. And there is no printfin anymore. Serial device equals dev. Okay. And the other, so we're going to return it, but we're also going to make global TTYs of ID TTY. And why are we doing that? Because that's where the file connection comes from. Is that, how far off building is that? Dev TTY. What? Didn't we fix that? Oh, right. We got rid of that function because it doesn't actually have to be virtual. It can be concrete, just to push the byte to, because there aren't multiple kinds of TTYs, so there's no point in making that virtual. We just have to make sure that we create the TTY push byte struct TTY. Okay, cool. That should build again, or be close. Conflicting because it returns an integer because everything is weird. And we're fine. Okay, so now fs2 serial for write, you go straight to the serial device. For read, you have to get the TTY. Oh, well, we already have that up here. We said 64. Boom. And so the fact that we've now copied that twice means we can make it a helper. Static file TTY. I don't know. fs2 file. So what was the first thing that the checking. Okay. So now TTY equals file TTY file if is error TTY return error. And now that can just be copied as 3 lines of code instead of me having to track that magic number across half the universe. This still has to be here because the serial device stuff is only for writing. Read, though, if so. If we're signaling UF, don't signal UF anymore, false, and return 0. That's easy. That's the basic case. Now, so I guess the next question is, we do a ring read. Ring read, ring data len. That should be very easy. So that's data len, and then if there is nothing there, WQ block on, or I can decide for some reason, you know, just experimenting with different sort of ideas of what we can name these things. In pipe, I made this aliases wait on WQ block on. I actually don't need wake from because we're not going to talk to the other guy. But I'm going to be consistent on that for now, and if we end up changing it globally, then it'll be changed globally. If it's in pipe, I'm going to do it here. So if we read nothing, wait on TTY to the wait queue. And well, okay. If it is not 0, then return. And now, so I think there's a big open question here around the new files world as to what am I supposed to do if this wait returns and there's no data still. In the past, I would just loop forever, and that was like behind an extra layer of indirection, so it was not exactly very easy to even get there. I want to be able to support core Unix. Originally had the idea that if a signal came in while you were in a syscall, the syscall would exit with you would go back to running user code with, I think it's einter. While blocked, waiting on the completion of an open of a slow device, for example, a FIFO, the call was interrupted by a signal handler signal. And then you can set a flag, which I'm sure there's info about in signal. Start sys. Restart. Yeah, here we go. If a signal handler is invoked while a system call or library function is blocked, either it is automatically restarted or it fails with the enter. And you can set it to always restart if you set this SA restart flag. I have historically taken the position that everything will always be restarted. And the thing that I'm not sure is there a use case for einter? Is there a reason that I would want to support that? Or does everyone want automatic restarts and that was just difficult when POSIX was created? I don't know how to think about that. So I'm redesigning the system. I haven't yet decided whether I want to do. I'm been considering doing like an omnibus, like wait on anything function that will return a code indicating why you were woken up. Were you woken up because of a signal? Were you woken up because there's now data? Some other reason. I don't know. I haven't written that. I've thought about it. I think for now this is fine because I do already have other mechanisms in place to make sure that you're only actually woken up when there's data. So this should be at least correct. And I think this is what I did for pipe. If not, we may need to reconsider what I did for pipe. I did a while loop. So yeah, I don't know. I don't know. I do not know. We'll see. We'll play with it. This one's also asymmetrical, right? Pipe is symmetrical because both reading and writing can block, and both the times you need to wake the other end. TTY is not symmetrical, so because you writing to a TTY right now in this system can never block because it just goes straight to a terminal. It doesn't do anything else. Okay, so we're like pretty close. And then the fs2 chardev.c we want to do basically the exact same thing here, just to register it. Except this is TTY. And then I think for now we're just gonna put it like this. We're just gonna sort of YOLO it in here. I don't like that long term, but it is what it is. I want this to be like a registration function, and it certainly can be for everything above index 1. All right. It does not seem to like my incompatible function pointer types. SIT star struct file star size t aka the with expression of size t aka long term struct star unsigned const void star. Okay. Did I use void in? I did use void. Okay. K. Okay. It's not minor device, it's device minor. That's not it. Serial, which should really be called TTY. We'll probably rename that. It's not minor device, it's device minor. And I did it again. Just simplify, consistent size. I'm gonna GFS. Okay. So yes. Okay. Serial, that's flat. That is not a pointer, that is flat. Okay, so. And that, okay. Where did I make global TTYs? Did I make global TTYs? I did. It's in kernel tty.c. We should put it in the header. It's right here. No? Didn't I copy that? Okay. All right, so what I want to do here, what do you mean it has incomplete type? It includes that file. Right? Oh, well, no, .h includes ngtty. So unless ngtty includes fs, it does include fs.h. That is not necessary. Circular dependencies. Okay, hello. Okay, I was getting a lot from that. My goodness. All right, so what I need stdef, I think, and maybe systypes. And you need to know about files? Why do you need to know about fs2 files? Oh, okay. TTY.h needs to know about ring buff. That's easy enough. And it makes sense. And then serial.c cares about incomplete definition of fs2 file. That's fine. Very sensible. Because I didn't include it. File h, inode h, and enode. Sure it is. Oh, I just don't have air now. Serial.c should return a value. Don't you love those? And fun fact, GCC, I think it's GCC, it might be Clang, whatever compiler I was using on whatever machine I was on, with no warnings, by default, will not warn you. Like if you just run CC, like would not warn you that you have a function that returns a pointer and you're just not returning the pointer. Let's see if that's the case on this machine. If I make a function called like make me a string, and just don't return, right? So doing a malloc but never actually returning it, and I just do cc. Okay, ignoring malloc, that's very reasonable. My string. So now I'm saving my malloc, but I'm still not returning it. I'm putting it in my string, but it doesn't get returned. No warnings. I've made a function that returns a pointer. I am using that pointer. Hell, let's dereference it. Not a warning without upping. It's W all specifically that you need. Always use warnings, kids. Never. If you compile without warnings, you're insane. Okay, so we build. We think we've more or less built the thing that we need to build. With one final exception, which is that we actually need to allocate the 2 TTYs. We need to pick a time and create them. And I think we're just going to do that in main. If we do that, we may stop crashing on boot. I don't know, maybe like up here somewhere so that we can print out. This is a horrible interface, but here we are. All right, and then x86com, we definitely don't have serial here, do we? But we shouldn't need it. Yeah, we should be able to just forward declare the struct and then extern so bad. I'm such a terrible human being, but it builds. And we crash in destroy child process. I think I know why. So 800. Yeah. So there's weird stuff happening. The reason for this is going to be that I've now moved the input output and therefore things like life cycles of whether somebody's typing or not into the new files system without moving anything else. So it's right now completely untestable. So I am going to commit this as is. I'm going to declare victory on the code that we have written so far, make a commit, and then start working on switching everything else over so that hopefully our life cycles will go back to normal, some semblance of normal. So let's make a commit. How evil. Yeah. Fix me. Ew. We need to put this in kernel main too. Okay, so we're gonna commit those things. fs2. Yeah, I think I know exactly what. I think I know the exact code path. It's so init standard IO file doesn't exist. I was expecting there to maybe be an error message there. There is not. There might be a crash somewhere else. It can't print anything, so that's what we need to fix. Cool. So, what do we have to do to move everything over? Well, let's start with that. Yeah, I know. Oh, so this header does not exist anymore. It has to be removed. Everywhere. How did we? Uh-oh. Okay. How's that for hilarious? FS is where this was getting sysret. Where is sysret defined? I don't see it. There it is. Syscall.h. Should probably be types or something, but whatever. Syscalls.h. Okay. Is that really where? No. So sockadder is in syssocket. Now we discover all of the header not unclean. What's the word I'm looking for? Header contamination. We discover all the header contamination, all of the silent dependencies that I've just not thought about ever. Did I really? How did I do that? Somehow this depends on FS. The FS2 depends on FS for some reason. Okay. Syscalls then needs poll FD is in poll.h. So syscalls.h needs poll.h. There is a body of thought that says we should get rid of this, my thought, that says we should get rid of that entirely. The syscalls.h header. I mean, what uses it? Very few things, actually. How hard do you think it would be to just get rid of it? It's such a pain because it the problem with syscalls is that it has to have, because it contains the prototypes of every syscall, it has to have every type that is used in any syscall in scope, which is why, right, you can see it's, even though the actual syscalls are in this auto-generated file, I have to include all of these headers because this is where every single, including syscall types, I have to include all of these because that's where all of the associated types are defined. And then you end up with all of these implicit dependencies, like debug was getting thread through syscalls, apparently. Yeah. This is the thing that I was worried about as far as like exposing lots of header problems. Like, yeah, okay. Debug definitely needs to have access to this, so it should just have access to it. This is, let's see, file.c has now lost access to standard lib, right? Like, I don't even know how I did that. I don't know. That was file.c. Well, that's C. Well, because it's not here is the answer. Kernel debug has lost access to Erno. I really wish there was an easier way to deal with this. fs2 dentry.c is access to Erno. Okay. Kernel main does not need fs because there is no fs. Also, there is no fs, so we can't do VFS in it. Make proc file. That's in kernel main. We haven't dealt with proc files yet. That'll be a later problem. Kernel mod.c. We haven't dealt with kernel modules. It should actually be really easy. We might be able to just do this in the switchover. Int fd instead of, yeah, so okay, I hate this. I'm just rewriting it. fs2 file equals get file fd. I need to know if get file returns. How does get file decide if it's an error or not? It returns null. Okay. If not file, okay. permissions checks. None of these things are exported, but we'll need to. Okay. Yeah, if okay. And then load it, and you're done. So we need to deal with the linker. Well, okay. Mod needs to actually know about this with a /file.h and probably inode in order to be able to look in there. Okay. Mod also had proc mod proc which has struct open file. I need to get back things like proc_printf, so this is going to be a little messy. So the thing that we're going to do right now is just change the prototype to be correct and then comment out the body. And this is definitely not too long. There's just no way that that's 80 characters. Yep, it's not. Thank you. Okay. Implicit definition of proc_printf. Proc test. Exec. Similar problem. No fs. File definitely necessary. There's no such thing as an FT buffer anymore. It's now called an FT normal. It's not the file, it's the inode. That doesn't make any sense. File inode data. Inode. Okay. That's that. fs2 file, star file. That's nonsense. This is file inode data. This is file inode len. S2 file. Let's go start file name. File mode. File. No, okay, so this is wrong. That's an inode. And that's an interesting point, is that these didn't mean file, did they? They meant inode. Yeah, they meant inode. So unfortunate consequence of this rename is that the thing that I used to call a file is now called an inode, and the thing that I used to call an open file is now a file. So there's a bit of confusion in the conversion process just because that's confusing. All right, so that is an inode. If the inode's mode is user exec, which should actually be if execute permission inode. Again, that'll need to be fixed. Exec shebang, we already fixed that. Inode. FS path is now called resolve path. That is a So now we want to change we want to change inode equals dentry inode dentry, but we need to decide if that's not possible, and the answer to is it not possible is if is error dentry or not dentry or not dentry inode. No. Actually, what is this? This is a sysrat. So I should just return that as is. If it is null, no, that's not true. In these two cases, I should return it as is. In this one case, I should return it as is. I should assert that it exists. In this case, I should return it as is. And if not inode, inode dentry, you know it. Okay, because if you resolve path a path that exists, like it's a valid path up to the end, except the file doesn't, like the path is fine, but the file doesn't exist, you will end up with what's called a negative de-entry. I took this from Linux, where you get a directory entry that exists in the directory tree, but it has no inode. It caches the non-existence of the file, so that, say, if you have a really slow file system like a spinning disk and multiple processes are asking, or the same process is asking, hey, does this file exist? Does this file exist? It doesn't keep going out to the disk, it caches the non-existence. So if the path doesn't exist entirely, you'll end up with something like an endoend out of resolve path. So if it is already an error, we want to return that error. But it may be the case that you get a valid de-entry that has no file. And then, inode equals de-entry, inode de-entry, and then it will do the right thing. Cool. If we open elf inode, exec interp struct inode interp equals resolve path, except that's not how that works. Same sitch here. This is not interp args, this is path temp. Interp equals dentry, inode, dentry. None of this really runs. Inode interp except for enough interp. Exec load elf of E, which we opened above. That should all be fine. Everything should be fine. Okay. That should be... It's not fine. That should have been everything that was necessary. Except, okay, so yeah. So, FS2. File. FS2. FG. No, D entry goes first. FS2. D entry. Inode. That should be a lot closer to reality. And we have lost access to air now from something else that we did. From removing fs.h. That's closer, except that include ng exec has ideas. It's not exec, it's thread.h. Yeah. So now we have to decide what we're doing about this, because I'm about to put it may be somewhat okay. Let's see if this works. If I can just say inode. No, it won't. So okay. Bad, but it's okay. We need to come up with some... I have to decide some of those headers are going to have to be public. The problem here is that the FS2 headers are all sitting in kernel FS2, and there is no reasonable relative path for me to get from include ng to kernel FS2, right? Maybe you could do it with like ... but these all get copied into different directories during the build process. So that is not a reasonable, it is not, practically speaking, it is not possible to refer from include into the kernel directory. So I will need to make some change. Unclear what, but I will need to make some change to make that work. But we appear to have gotten a building with that. So, or at least, well, yeah, I don't see it in this list. So we've at least got some different problem, which is that this needs syscall.h. How convenient. Are we, how far did we get on getting rid of syscalls.h? Can I actually get rid of it? Do I need that here? I know we're doing two things at once, which is evil and bad, but it's okay. I see. Well, where does this get called? The system call is here, and it uses fsResolve relative path on a file name. So we can actually simplify this quite a bit by not passing an inode by passing a directory entry. And then we're basically going to do the same thing up here again. Entry inode dentry. Cool. So yeah, that means that we can just use the name of the directory entry for the common. So we don't need to worry too much about that. That's sweet. And then I just need to make sure that I'm not redeclaring struct dentry. No, I was, yeah, that's fine. Okay. So this then needs to change pretty dramatically too, because it's going to be dentry it's actually just literally going to be that, because we already did all the checking in there. Cool. It's conflicting types again. Conflicting types can be solved. All right, kernel PMM has a proc file, which is why it needs fs. Fs also includes the rest of the world. PM summary, which we are going to change out for fs2 file, and then delete everything inside of it, because we have to solve proc files. Okay, so auto-generated syscalls kernel needs the prototypes. Can I give them to it? Can I say auto-generated syscalls kernel? Can I say apparently yes, maybe, we'll see. Why are you upset? NGFS. You have an NGFS because you have a proc file. This is definitely not 80 characters. In space star. That's close, that's for sure. It might be okay. It's not okay. Damn. Never mind. I misjudged it. Okay, you have a... Why do you have... Oh. For mmap. Okay. this is something that I use in very, very few places, so and that I would want to change pretty significantly anyway. Include ngpmm, pmm. This was already doing that. Kernel main cannot have a struct open file. This has to be fs2 file. All right. What are you upset about now? Okay. Well, here's more. Well, okay. This is going to be so much simpler. Boop. Solve at path dir fd file name. Done. There are other things in here, proc threads, but that is so much nicer. And we need to do deep copy and close all open FDs. So we can't really just wholesale copy or find and replace this. Open slash fs2 slash g. So deep copy definitely needs to happen, as does close all open FDs with this. Not solved yet. Ugh. Okay. Make proc file. Later problem. Sys exec v. What do you mean that's... Oh, because I'm not declaring that. That's sysret. No, I can just... Yeah. No, I shouldn't have done that again. Yeah. CWD can just go away because we already have the replacement for that, I think. Right? Why was it being set in 3 different places if... Well, that's also wrong. I mean, it's... No, it's wrong. The new thread CWD should be the old thread's CWD. How does the first thread get its CWD? That's fine for no, it's not fine for now. That proc 0, I think we have to do this in init. Yeah, proc 0's root should be global root the entry. Thread 0 CWD, actually that should probably be, we should make init do this, right? Yeah, we're gonna make init change to the home directory when you log in or something like that. I shouldn't have done that. Other screen. Come on. I believe in you. Okay, we got a couple of other files. Kernel timer just has a proc file, I think. No fs, proc file. S2 file. Is the word file anywhere else? No, it is not. Auto-generated, great. Okay, so that didn't work. Kernel pmm.c unused function. Fantastic. That's just a big no. I'm doing a big refactor. -w, no unused function. Unacceptable. All right, so we're back to that. Yes, okay. Include ng thread CWD needs to no longer exist. Indeed, so does FDs. region struct file star file. What we're going to do is we're going to make ngfs2.h, which should just declare barely enough to get it to build. Okay, so in then kernel thread, every instance of CWD needs to be fixed. Two. Well, yes. Did we already do this? I guess not. I thought I did. Oh, that's in clone. Yeah, I'm kind of not surprised I didn't do that. Init thread 0. Yeah, okay. Good. I need to stop doing that. Clone open file. That actually needs to exist. That's very important. I wonder if we can do this. FS2 file. There might be a place for this. I think there's always an inode. Pretty sure there's always an inode. There should never be a file that's open with no inode. I can just, sorry. Presumably there's should be something similar for a file, inode file ref count. I don't think there is one though. Later problems. And everything else is the same. So yeah, which is why there's no point in copying them one by one, because the whole point is that everything is the same. But oh right, because yeah, there is a thing to do here, which is say inode to we need to update the .h read and write ref count incremented by open file. Do I actually want to? I don't think I actually want to call open file though, which is a little unfortunate. Inode. Oh, okay. It actually does, well, it does all of that stuff. So probably, maybe, probably what I want to do is say like, if we are cloning, do not bother. Open file new true. If not clone. I know, now I have to go update. So, and then that sets the read-only flag, the write-only flag, the directory entry flag that does everything correctly. Close does not have that problem. I wonder what files actually use ops open. Open equals, presumably, in FS2, in kernel FS2. It may literally be nothing. It is literally nothing, so we'll see. FS2 definitely syscalls has open files. I am very interested in making all of these go through the same code path, just so that I'm always confident in these entries. I'm always confident in the ref counts, and I'm never like worried about the ref counts being wrong. So we do definitely need to have some close functions, though, to make sure that we flush things like pipe locks. We do that, don't we? Didn't I already make one of those? Yeah. Well, okay. I made the inode operations struct. I guess the TTY doesn't really matter. Cool. Problem solved, hopefully. Yes. We're just gonna do this that way, so that we don't have to deal with it. Okay. TTY has no... Yeah. And we have to deal with all of the in threads. Yeah. This is really... I mean, I sort of knew that this was going to be a real bit of a spider of a change. Spreading its legs out over everything. But this is really getting kind of tiring, and my arm is starting to hurt. So I need to change positions, which means I'm going to call the stream here. I hope everybody has enjoyed. This will be up on the VODs, obviously. Always feel free to reach out if you have any questions. Thank you, and I hope you're having a great day.